All right, so surface area number 5, surface area of pyramids and cones. So here's a pyramid, right? And it's unfolded. By now you've done enough nets. Can you see a pyramid unfolded in your mind? Here, this is one of the best from last period, right? Think of this and then think of the sides undoing like a flower, right? And then each of these shapes becomes your surface area. So what shape you got on the bottom?
Square.
Square. What shape do you have on this side?
Triangle.
Oh, how many? 1,
4.
2, 3, 4. Fair enough. So surface area, I don't know if it helps you to unfold it in your mind, but 1, 2, 3, 4 triangles. So 1/2 base times height times 4. Now if 4 is divided by 2 here, this becomes 2 times base times height. So it simplifies a little, but it might be even easier to leave 4 triangles in here. And then the base is here. Now, just to give you an idea of what these terms are, the base is this dimension from here to here. This would be B, the base. And that's, see the base of the triangle right there? So pull one of the triangles out. Let's do a Dorito. There's the base. Here's the height of it. Okay, so from here to here, H, and I didn't make them capital down here. I did lowercase b and h, but b and h. Notice that it's the slant height of this thing. So height is the slant height. What does that mean? Don't hold the triangle like this and do the height. Remember the perpendicular we've been doing all the time? We've been doing perpendicular height. Now all of a sudden, you need the slanted height. You need to take the triangle as if it were flat. Otherwise, you won't get the true area of that triangle. So interestingly enough, we've been doing altitude and perpendicular height on almost every shape, and now it switches for this one, right? So you need slant height for this. Okay, and then go to cone. Here's a cone up here. What's the shape? Oh, I don't have a very good example of this yet, but maybe this class will produce one. This is kind of my best example at the moment. Okay, what shape's on the bottom of a cone? Yeah, on this one, a square. Okay, no, it's a circle. It's supposed to be a circle, you guys, okay? So circle, so you've got 1/2, you got pi r squared, right? And for some reason I wrote pi, but it could be pi r squared. So that's the area of a circle right here. And then when we unwrap this thing, it looks something like this. It looks like this kind of shape, okay? And this one's a little bit more difficult, but there's a slant height of this thing, right? This thing has a radius that comes around, or a height here. So the radius, so what we have is a pi, the radius being this distance from here to here, radius, r, and times the slant height, which is this distance here from here to here. But isn't that the radius squared? It is. I better check that one and get back to you on that one. Pi radius, oh, let me check it right here. So, pi radius slant height. Oh, duh. I'm sorry, you guys. They're using this radius here. Why am I doing this? I apologize. Let me correct this right now. This is the radius on the bottom times the slant height here. So, we're not calling this the r. We're going to call this the slanted height, okay? So from here to here, this is the slant height. And this is the radius here on it. So the radius of this circle here is the r. So pi radius times slant height. I'm sorry, I got a brain tick right there for a moment. All right, and that'll give you the surface area of the whole thing. When you do the 3D shape, if you give yourself some tabs on this circle, that'll help you bring it together. And if you do a tab here, that'll help you bring it together. Okay, done.